yaw joint. This will provide the capability to change out one of the joint segments on the space station robotic arm if necessary. Additionally, there are 2 direct current switching unit ORUs, which we're going to remove and transfer up to space station as well. Each of these ORUs finds their home on the ESP2 pallet. Rick Linehan will come around the backside on the underside of the pallet and install the SSRMS yaw joint. He'll make a round trip back to the payload bay to retrieve the first DCSU. Once he has that ORU, he will be installing that onto the top of the pallet as well. Make one last round trip to the payload bay to retrieve the final ORU and install it on the ESP2 pallet as well. It's going to be a pretty busy EVA for Rick, so that's going to be the end of his tasks. Bob Benkin, after finishing up with the SLP cleanup, will come down to the payload bay and retrieve the material experiments packages. These are about briefcase size experiments, which he'll translate up to the Columbus platform where Rick had installed the base for these experiments. He will then open up the briefcases and expose the material experiments to the space environment. That wraps up EVA 3. EVA 4 will start off with the RPCM, or Remote Power Control Module, R&R, and a patch panel reconfig. Both of these tasks will enable the space station to have redundant power capability to the control moment gyros on the space station. So the crew will come out of the airlock at a very coordinated time with the ground team. Bob Benkin will translate up to the top of the S0 truss, where there will be a bank of RPCMs behind a door. He will work on changing out that RPCM. At the same time, Mike Foreman will translate up around the aft side of the Z1 truss module, where he will perform the electrical connector reconfiguration. Again, this provides the redundant power capability to the control moment gyro number 2. At this point, the ground is going to be feverishly repowering up the hardware that had been shut down for that exchange. And the EVA crew will go to the airlock and retrieve the hardware that they need for the tower repair detailed test. This will involve relocating a foot restraint, installing a tile sample bag, and a large ORU bag that has a bunch of the support hardware for this test. Mike Foreman will ingress the foot restraint. You can see him here in the position he will be over the tile samples, with Bob Benkin free-floating around that bag to help him out with tool logistics during the test. Once the crew is finished dispensing material and finalizing the samples, they'll take the sample bags and the hardware down to space shuttle payload bay, where they will be stowed in the tool stowage assemblies. This will allow the materials to continue to cure and harden in the vacuum environment until they can be reviewed by the ground team. The hardware used for the test is also going to be stowed outside. This is to protect any contaminated material from coming inside, and it may have a little bit of effect on some of the environmental control systems, so we want to leave as much of the dirty material outside as possible. Coming into EVA 5, again, this will be performed by Bob Benkin and Mike Foreman. Coming out of the airlock, the space shuttle arm will have the boom grappled while the crew translates up to the S1 truss, excuse me. In order to protect the boom while it's left on orbit for several months, it needs to have heater power supplied to the sensors to prevent them from freezing. In order to get this power, the crew is going to install an avionics box, shown here, into a camera port, and this basically will convert the space station power supply and regulate it down to the 28 volts needed for the sensors themselves. Connected to this box is about a 30-foot power cord, which the crew will plug into the base end of the boom later in the EVA. Once that stanchion is installed with the avionics box, the crew will set up a foot restraint and get in position for the space station arm to bring the arm into proximity. While we're doing this, the space shuttle arm has handed the boom off to the space station arm and maneuvered it up into position. We're doing this with very heavy coordination to keep an eye on the thermal clocks and make sure there isn't an extended period of time that they're powered down, and make sure we have good sensors to leave behind for the 1JA mission. Bob Benkin will ingress the foot restraint, install the power cable to provide power. At this point, we can restore power to the boom and stop our thermal clock. Once that's connected, the space station arm will translate port into a position where it can hand off the boom to the EVA crew members, one in the middle and one on the far end of the boom there. They'll grasp the boom from the end effector and install it onto the stanchions which were left behind from STS-118. This will be the mechanical interface between the boom and the structure. Finally, at the end of this, Mike Foreman will be installing a thermal cover on the end of the sensors, and this provides some additional thermal protection as well as micrometeorite protection to protect the optical surfaces. From there, the crew translates out to the solar alpha rotary joint, where they have a trundle bearing to install. This trundle bearing was removed on a previous mission and brought to the ground on the 1E mission for ground investigation. There's a spare which is currently on orbit. Basically, it's a pretty simple interface, has a series of 3 bearings, 3 bolts. It clamps around the outboard part of the truss and allows basically the main mechanical interface between the fixed inboard side of the truss and the outboard truss segments. Once that Sarge trundle bearing is installed, the crew is going to go and do an inspection of some of the areas of the Sarge of interest from before. This is a picture of one area of concern we've seen during previous inspections. There is an interesting little feature we've seen on what's called the datum A plane of the outboard race ring. And from the imagery that we have now, we can't quite tell if that pockmark there is a piece of surface debris that's stuck on the top of that can be just wiped off, or if it's actually a divot or hole into the metal structure. Certainly the latter would be a much greater cause for concern, because it may be the beginning of further damage that can then propagate from here and cause further damage to that race ring. So we really want to understand what that is and if it's going to have downstream impacts for us. From that point, we're going to go inspect 5 other covers on the Sarge. The point of these inspections really is to try to narrow down the fault tree and what caused the damage on the alpha joint. We're going to be removing the covers and looking for potential micrometeorite debris damage. If we don't find any, then that can close out that part of the investigation. We really think it's key to understand exactly what caused this damage, so that if we do go to outboard ops and use our backup ring, we don't get ourselves in the same situation where we are now, and we can preserve that ring's integrity.
The third spacewalk is scheduled to begin in just a few hours at 6:23 p.m. Central Time.